In this episode, we focus on a problem that every cloud security team eventually faces: too many alerts and not enough clarity. It is one thing to design detections for identity abuse, lateral movement, and data exfiltration, but it is another to ensure those detections are usable in real life. If every unusual login, every new connection, and every volume spike triggers an alarm, analysts quickly become overwhelmed. Over time, constant noise leads to alert fatigue, where real threats are buried in a sea of low-risk events. The goal is not to eliminate alerts, but to tune them so that high-confidence cloud security alerts rise to the top. By the end of this discussion, you should understand how to refine detection logic, incorporate context, and adjust thresholds so that your monitoring remains sensitive to real attacks without becoming unmanageable. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Noise in cloud detections usually comes from treating single signals as definitive evidence. For example, a login from a new geographic region might trigger an alert, even if the user is traveling or using a corporate virtual private network. A new network connection between services might generate an alarm, even if it was part of a recent deployment. These signals are not useless, but they are incomplete when viewed alone. High-confidence alerts typically require multiple related signals that together suggest malicious intent. Instead of alerting on every unusual event, tuning involves combining signals so that only meaningful combinations generate attention. This approach reduces false positives while preserving visibility into genuine compromise patterns. One of the most effective tuning strategies is correlation. Rather than triggering an alert on a single anomaly, design detections that require a sequence or cluster of suspicious events. For example, a login from an unusual region followed by immediate privilege escalation and sensitive API calls is more concerning than any one of those events alone. By linking events across identity, network, and control plane logs, you increase the likelihood that an alert represents true risk. Correlation can also involve time windows, such as requiring multiple failed login attempts followed by a successful one within a short period. This method ensures that random noise does not constantly trigger alarms. When detections are based on relationships rather than isolated anomalies, confidence increases. Threshold tuning is another essential practice, particularly for volume-based detections. If you set thresholds too low, routine fluctuations in cloud activity will generate alerts. If you set them too high, attackers may operate below the radar. Effective thresholds are informed by historical baselines that reflect normal behavior for each workload or identity. For instance, rather than using a single global outbound data threshold, you might define thresholds specific to each system's usual transfer volume. Dynamic baselining adapts to changing environments while still highlighting meaningful deviations. The key is to tune thresholds gradually, observing how alerts behave in practice and adjusting based on real-world patterns. Detection tuning is iterative, not a one-time configuration. Context enrichment significantly improves alert quality by adding environmental information to raw signals. For example, when a detection identifies a new outbound destination, it can be enriched with data about whether that destination has been seen before, whether it belongs to an approved partner, or whether it was recently registered. Similarly, a suspicious login can be enriched with device posture, authentication method, and user role. Enrichment transforms simple alerts into contextualized insights that are easier to tree off. Analysts can then make faster decisions about whether an alert requires escalation. By embedding context into the detection pipeline, you reduce the number of alerts that require deep manual investigation. Another tuning technique involves risk scoring rather than binary alerting. Instead of treating every anomaly as equally important, assign weighted scores to different signals. For example, a failed login might add a small amount of risk, while a privilege escalation might add more. When the cumulative score crosses a defined threshold, an alert is generated. This approach allows minor anomalies to accumulate into meaningful warnings without overwhelming the system with single-event alerts. Risk scoring also reflects the reality that attacks often unfold over time rather than in one dramatic moment. By modeling risk as a continuum, you create a more nuanced detection system. Feedback loops are crucial to maintaining effective tuning over time. When analysts investigate alerts, their findings should inform future adjustments. If certain alerts consistently turn out to be benign, their thresholds or correlation rules may need refinement. Conversely, if incidents occur without triggering alerts, detection coverage may need expansion. Continuous improvement prevents detections from stagnating as environments evolve. Cloud architectures change frequently, so tuning must adapt accordingly. A static detection rule may perform well initially, but become noisy or ineffective as workloads scale or architectures shift. Suppression and filtering mechanisms can also help manage noise without sacrificing visibility. For example, alerts related to known maintenance windows or approved deployment events can be temporarily suppressed. This prevents predictable activity from overwhelming monitoring systems. However, suppression must be carefully controlled to avoid creating blind spots. Suppressed alerts should still be logged and reviewable, even if they do not generate immediate notifications. The balance between suppression and transparency ensures that convenience does not undermine security. Controlled filtering refines signal quality while preserving auditability. Segmentation of alert categories further enhances manageability. Not all alerts require the same urgency or response workflow. High-confidence alerts related to privilege escalation or confirmed exfiltration attempts may warrant immediate action. Lower confidence alerts might feed into trend analysis or periodic review. Categorizing alerts by severity and confidence level prevents teams from treating every event as a crisis. Clear prioritization reduces stress and improves response quality. Over time, teams become more skilled at distinguishing between urgent threats and background anomalies. Automation can support tuning by handling repetitive triage tasks. For example, automated enrichment can check whether a suspicious IP address appears on threat intelligence lists or whether a destination domain was newly created. Automation can also close low-risk alerts automatically when contextual checks confirm benign behavior. However, automation must be carefully designed to avoid suppressing legitimate threats. Human oversight remains essential, particularly for high-impact alerts. The goal of automation is to reduce repetitive workload, not to replace judgment. Balanced automation enhances efficiency while preserving investigative depth. It is important to recognize that some noise is unavoidable in cloud environments. Dynamic scaling, global access, and rapid deployment cycles naturally create variability. The objective is not perfection, but sustainability. If analysts can process alerts effectively without burnout and still detect real threats promptly, tuning has succeeded. Regular review meetings to assess alert volume, false positive rates, and missed detections help maintain that balance. Metrics such as average time to investigate and percentage of high-confidence alerts provide measurable feedback. Tuning is both technical and operational, requiring collaboration between detection engineers and response teams. Transparency and documentation also support effective tuning. When detection rules are adjusted, the rationale should be recorded. This ensures that changes are understood and can be revisited if necessary. Clear documentation prevents confusion about why certain alerts are configured as they are. It also supports audit and compliance requirements by demonstrating intentional and controlled monitoring practices. Well-documented tuning processes reflect maturity in cloud security operations. They show that detection logic is not arbitrary, but grounded in evidence and experience. In the broader perspective, tuning detections is about maintaining trust in your monitoring system. If alerts are consistently meaningful, analysts remain attentive and responsive. If alerts are mostly noise, they lose credibility and may be ignored. High-confidence alerts emerge from careful correlation, contextual enrichment, adaptive thresholds, and continuous feedback. These principles ensure that detection systems evolve alongside cloud environments rather than becoming obsolete or overwhelming. By refining your detections thoughtfully, you create a monitoring framework that highlights true compromise while filtering out routine variability. That balance sets the stage for effective alert investigation, where context determines whether behavior is benign or truly malicious.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.